Hey guys, it's Realm time now. So let's get started with integration of Realm with the existing application which we are already developing, which already has RxSwift integrated. So it'll be pretty interesting to see how we can actually get Realm and the RxSwift working along with the view models. So let's do it. First thing first, let's add a database. Oh, even before that, let's add Realm. For that, if you go to realm.io, their website, you'll see the link to add the pod file. Go to your pod, include realm there, and install. It does not take much for me because I had already installed it. But if you are new, then it might take a while for you. So let's close and open. And do a clean build. And by the way, I'm using the new build system of Xcode 9, which as per Apple will improve your building speed way better than what it used to be before. So this is something which you can check out. The build new system, by default will be standard build system. As the build is complete and successful, let's go to our project and create. I want to abstract the Realm part, so I'm creating a database file for that. And import RxSwift. Make this a singleton. That's my singleton, and create the functions required. So I would require a create or update. It might accept my to-do item value, and I would need something to fetch so I would need to fetch everything maybe. So just return something called as a results. So even before this, let's keep it as void because we have not yet created the realm file or the table which we need to use to process the to-do items. So before that, let's all create all the functions required. I would require a delete function which might accept a primary key. I'm hoping to keep it as an int. So I have create, fetch and delete all integrated. Let's now create a to-do item realm file. So this is the actual realm object which will help us to persist the realm data. Import and we create some properties, so it needs to conform to the dynamic var that is inherited or it being derived from the Objective-C side. So let me have a to-do ID will be of type int. Let me just initialize it, and then let me have a to-do value. This should be ID. To be string, then initial value. I'm going to have a created date. Call it created at type date. I'll initialize it with the current date whenever that object gets created. I'll have an updated date, no initial value, and we also need to persist is done. Type bool and let it be false initially. So we have the realm things in place. One more thing that we can do is to have a primary key. For that, we need to call string and then return the primary key. Let it be the to-do ID, which will be unique. So I have the primary key also defined. So this is typically representing my to-do item persistent data side. So that being done, let's go back to our database. So what are things we need? Let's start with the fetch. So if I am fetching all the record, then realm will return something called as a result set of my realm object, so which I just now created the to-do item. It will be a type of results. Go to the definition, that's something like this, which is like a collection object. So to access a realm instance, all you need to do is to call the realm object directly along with this try block. So that will create your realm object, which will help you fetch all the realm database objects in memory. So in my case, if I want to fetch all the results to do items, all I need to do is call objects to do item of this type. So this will literally fetch me all the to do item results. So this is what I'll be returning. So the return fetch side is done now. Does not give you an error, so that's pretty much done. Now let's do the insert part, where I'll again create an instance of realm, but ideally it's not actually creating multiple instances, but it is actually accessing the default realm instance always. So if in this case we as we don't have multiple databases required, let's say if there is a case where you need if you have multiple users logged in, then in that case it makes sense to have different configurations or database created for each user. In that case, you can design or create configurations for each user. That is not in scope of this tutorial, so let's do that in the coming ones, where I'll be actually including to-do items for different users who can log in and do this. so where we can actually see what will happen there with different configurations. Currently, let's stick with the default realms and the realm instance, and then let's do this create part now. So if I'm creating a to-do item entity, and let me call it entity. So for creating that, all I need to do is to just call it as a normal Swift object, and then create that instance. And if I want to set all the values required, to do item entity, that's my value which is being passed to the item value. And if I have to set a index which is always incrementing, I can do some trick here. Realm does not directly support auto increment, so that's something we have to do on our own. It can be either UDID or something, but in this case UUID. In this case I'm just relying on the index of the previous last item. So let me just create that. For getting the last entity, all I have to do is call realm.object, the same stuff which we did earlier, to do item dot self, then just call the last. And if let's keep a variable index, maybe call it to do id without any initializations, default. Let's keep it 1. If there is nothing, let's set it to 1. Or if last index exists, then we'll just pick up this to do item index and set it incremented by 1. So this is a simpler way, or a way of doing the auto increment if it's like a small database which is using integers something, but not a good way of doing it. But yeah, for this tutorial it makes sense to do that. So if to do item is set, to do item, let's set that as the id, to do id. That's done now. Let's keep doing. Anyway, the to do item is done, is already set to false, so let's not set it again. Let it take the default value. So created, it is also done. Updated, we are not yet updated, so that's it. Now let's add it. So all you need to do is call try, and then use the created realm instance, and then call the write transaction function, and within the closure add the object to do item entity which we created. So one more thing which we can do as a safe step, as we are calling it create or update, the realm is providing something called as update is equal to true. So whenever it finds that the to do item id is already there, it just updates the object instead of inserting a new one. So this is a sneaky way, or a neat way of handling updates. So that being done, we have the create or update ready. Now the last part is to delete. Similar thing, try realm and call the realm.write, and within that you need to just call realm.delete, pass the object. So we need to access the object for this. Excuse me. Primary key, need the try block, otherwise it will give you an error. So let's access that to do item entity, and there is a function called object. So you just need to pass to do item.self and the primary key. This will fetch you the object if it exists, and then if it exists, we'll delete it. As simple as that. Delete is also done. So what all we have right now, we have a create, we have a fetch, and we have a delete, and we will be exposing this database through a singleton. So let's go back to our view model where we need to have it. So let's go back to the view model. Where do we have it? We need to add it in the to do view model, where we'll create an instance of the database. Database is equal to database singleton. That gives us a singleton object. So these are some of the hard coding or mock values of to do which we added in previous tutorials, where we were just showing the mock ones. But let's get rid of that. Let's comment it out. We don't need this anymore. Maybe even just remove it, because we'll be relying on the persisted data to do all this. So once that is done, now nothing will load once we run the application. So as a first step, let's start with adding. But maybe even before that, let's fetch the records. Nothing will load, as you know, there's nothing available data. Just call the fetch, and let's store it. So this is our to do item results. We're fetching it on init. We have it now. And what can we do with this? We only have the to do items. So Realm is providing something called as a notification token, which we can include to listen to any changes like an insert or even initial load, and if there is later an insert or update or delete, whatever happens, it get to that particular collection, like this result set. If something happens to this result set, we will get a notification. So for that, let's include that. Let's call it notification token. Tag notification token. It's done. We have the init. Let's also have the init, where we will set the notification token. And we can call it invalidate here. This will get invalidated as soon as it's the token, the init. So how to create this notification? It's very simple. We have to do is on the result set, write an observer. So let's go to the documentation of notification. So for collection notification, all you need to do is write and observe and call the change set collection. It's my block. So of type realm change notification, realm collection change. So let me call it as changes. Collection change. That's done now. So once I have it, because I'll be using some of the references, we call the weak self here, and have the switch case, the changes. So change can be different types. It can be initial collection change. This is when the notification listens to all the existing records which are the to-do items. If there is something, then it gets loaded during the initial. It can also listen to all the updates. We don't need to track the collection type, and it can listen to all the deletions, insertions, and modifications. You can see that it's a collection of integers. So what happens is whenever there is a change happening to an item, you will get a notification where it will return a result set, an array of all the indexes where the changes are happening. So let's say I delete something in that collection, so I'll get a notification with the deleted index array where I can loop through and find out. That's not ideal case because once deleted you won't have it changed it. That's one problem, but we will discuss that later. But on insertion, if there is a new insertion happening, then you will get a change set here with all the array indexes, and you can query all those things in this and create your view models, which we are already doing. On these changes, we access this creative view models and set those values into the items collection. So let's do that. So I'm listening to all these things. And finally, if there is an error, it keeps track of all the errors. So mostly we will not have that situation in this case, but yes, this is what we need to do. So as a first step, what are we trying to do? We are fetching the results on initial load. We have to move the sorting algorithm here. Sorry. So instead of on to do done, let's move it to this notification block after this. So this is more like whenever a change notification is whenever there is an initial, let's say a load happening, after the processing is done, it will sort my collection based on the earlier ones where the done things goes at the bottom, etc. That happens here. So triggering some changes already. That's fixed. So we are at a stage where we can run and see what happens, because initially, because there is no data created, it'll just show nothing. So let's run the app and see, just to sanity, to see whether nothing is broken. As expected, there is nothing in the table view yet. So let's start building those. So I need to start with the create part. This is my add item where I receive the new value. It used to index based on the count, etc. before, but we don't anymore rely on the view model because that's not the single source of truth right now. It's a database. So let's go there and do those operations. So what do we need to do now? The item index, let's just have this code moved to the initial part where, not the initial, we have to move it to the insertions part. So initial, nothing has happened yet, but we need to have the code there. Let's start with this because that's where we will have things working. So what will be the item index whenever we are inserting? So let's call the insertions, loop through each index. So that's insertion index, and whenever it identifies that a new item has been added. Let's call it to do item entity. We have the to do item result. Use the index which will fetch us the entity. Now we will use this entity to create the view models. For that, let's move this inside. We just move this back to where it was because it's more like something which needs to happen after insert. Let's keep it there. And on insert, whatever we need to do is to use this entity gives an error. And we have the to do item ID available. So after receiving it, that's what we will be setting it, because we are storing the index in the database like we had done it earlier in the DB. When we create, we are trying to find the index. If it exists, we are setting incrementing it, else it will take the default one. So that's being taken care in the DB. So all that we are doing is fetching and then transforming it the way we want it, like it's a string representation. And the next thing is to send the new value. So that will be our to do value. That's also set now. So this seems to be okay right now. So what we are doing is, whenever there is an index addition happening, when there are insertion happening, finding the index, trying to find the object and creating the view model based on the values coming from the realm side. Fix everything. So ideally this should make the insertions work now. So we missed out something here. We need to call the db call database dot create or update, pass the new value, and after that set this to this. So pretty much there. Let's run and see what happens. So on insertion, we are expecting this to trigger and get us the index. Let's do all the whole things. Washing clothes. That triggered and we received the index. The object is already created. It's adding it index 0. Let's see whether that is already there. That's it. It's already added to the DB and it has a created date, ID added, value, everything. So this should ideally create us the view model and populate using RxSwift like expected. It's adding now. So next thing is clear logic. You'll write later. Then wash car, the second item, it should add with index 2. It's adding pretty well, so we are pretty good there creating things, but we still have lots of things to do. Remove, done, everything. So let's get with that. So another thing that we need to now see is initial load. So we already have a couple of things on initial load. Let's see, something gets loaded. Nothing should load because we don't have the code here. This is where it gets called. We need to create the logic there. So you see there is nothing. So let's do that. So on initial load, all we need to do is fetch this to do item entity and then build the same logic. Like, we don't need the index because we already know the to do item entity. Same process, loads it and then sorts it based on the state. Let's run and see again. It should ideally load it now because we have added a couple of things. Let's keep a, maybe we don't need to keep a breakpoint because we know the value is coming back. Pretty good, it's working. Let's add a third thing just to see whether the index is not messed up. Pretty cool, it works. So let's keep continuing whatever we are doing. Let's modify. We have handled insertions. Now the step is to delete. One of the tricks about delete is that we are if we were directly using realm to bind with the table view, we could have easily done it that we just could have reloaded table view because index does not matter here. But the problem is here we are actually sorting, and if we do a sort, then index goes for a toss. Whatever we send as a delete will be received on the realm side database. It will delete it, but after it's deleted there is no way to track it, the delete feature. Whatever I'm saying, I can prove it just by implementing the delete here. Let's call the, instead of insertions, even before delete, let's implement done, where it will be pretty evident what I'm talking about. So let's implement the done. So done used to rely on the index of the item where we were just toggling. So instead of that, we can get rid of, not get rid of totally, because we will be using this index again to fetch the to do item. Let's move it somewhere here because that'll be a delete. Index. This is, as you can see, this is using index. It's not there anymore because it's already deleted. Let's say let's say I'm deleting the last item and I try to access it again. It's gone. I guess it makes sense to not have it here at all. And then let's not rely on deletions. Instead, let me just keep it in modification, which is more like updates, where you will receive the values and you can track it. Let me just keep it there. For updates, I have the same kind of things, and if there is an update happening, I can track the item based on the to do ID. So this being string, it's more like a string comparison. So whatever I can do is to make this both match. So I'm heading to do something like a hack where delete can work. It's more a reliable way of doing it, something called as soft delete and then hard delete. So for that soft delete, even before that, let's implement on done feature, because delete is like a little complicated and different. Not complicated, but It's more like a nicer way of doing it instead of this current way where index is lost. Even if we get the index, item is not there, so we will not be able to track it. So on done feature, whatever we'll do is we have this index, it's tracking based on that index which we moved right now there. We don't need it anymore. And we are capturing that index and get the to do item view model, set it's done, all this feature there. Let's move it there. Go to the modifications part where it is fetching the to do item. Let's call it view model because we have an entity and a view model now. And is done is being used where it'll be using the entity value is done to set it whenever there is a modification happening to that. So also whatever we did with the menu items is valid, but it again depends on the entity value. So let's do that, relying on that single source of truth, which is the DB. So every logic is moved now to the modification side because is done is something like an update which we will do, which will update, and the notification will come here. So let's see what we have done. We are tracking the index, still error. So we are tracking the index of the entity, the to do item entity, and getting the index of the item based on the ID, to do ID, comparing the entity and the one in items view model collection, getting the index of the view model, getting that specific view model item, setting its is done using the entity's value, and then modifying the menu based on whatever we have. Let's define, let's use it here. Is done from the entity, all decided by the entity, and menu items based on the value. So this looks like will make the is done work now because we'll receive the modification, it'll do it here. Let's go back to on done, do the database call. We don't have it yet, so let's go there. Go to create that, let's call it is done, pass the primary key, use the same approach. So same thing we'll do. Instead of delete, we'll just call, we'll use the to do item value, entity value is done, just toggle it to whatever it was earlier. So toggle is happening here and it gets returned to the persistent layer. So that's all we need to do. Pass the primary key, get the object, set it. Let's go back to our site where we are setting the to do database, call these done, pass the primary key, to do done. This should trigger the modifications where process will happen. Let's see that. Some more error because it's string, it's expecting int, so we know that there is a value which can be cast to int. Still we have errors. again. That looks to be fine. So if you're not set anything as done, if you do that, let's see what happens. It's working now like expected. Undone, makes it. So that's built now. The problem I was talking about now starts here. When I sort it, I delete this. Actually, I have deleted an item with ID 2, and it goes to the DB, deletes our item, gives me back the index of the item which got deleted, but I will have no track of which one got deleted because Realm does not keep a track of it. So as a way of doing this deletes, let's create our soft delete feature which I had just discussed. So for soft delete, first thing that we need to add is, just like in web projects where we do it, we will create something called as deleted it, which is like tracks the date at which, or something like keeps track of when an object got deleted. So that's done. Let's go back to create a function called soft delete primary key. It's done. And using the primary key, we are pretty much doing something like this, where instead of this, I'll just say deleted it at this particular date. So when on the date on which you are deleting it, you will do a soft delete like this. I will set the value. So right now whatever happens is, instead of the callback received in the deletions, we will get it within the modifications because the object got modified. So now we'll be able to track that particular item. So first thing that we need to do for that is, this was more or less tracking the is done. So even before that, what we can do is, if deleted is not equal to nil, checking whether the delete has happened or not. Excuse me. If a delete is deleted as it is set for this particular index, if that is set, all that we will do is to remove it from the selected items index. So we need to again track the same thing. Instead of doing all this, so maybe let's just move it here, and then so that's the index of the view model which we are tracking here. So this will remove the item from the view model. So now we are in a safer state where we can remove it completely, delete it, hard delete it, using the entity ID. So now this will delete the object. Let's return. do all the other things. So all we are trying to do is, if entity deletion has happened, then we'll just move it to the delete phase. So now this looks fine. This gets removed from the view model and then triggers a real delete. So we have to modify the delete here. We don't have it yet, so let's do that. We were directly removing from view model previously. Instead of that, we don't need this index logic anymore. All we will do is database dot soft delete using the primary key. Pretty simple. It'll set the delete status, which will trigger a callback, and using that callback we'll be able to delete it from the view model. That in turn will lead to the permanent deletion from the DB. So let's again, it needs type. It's pretty good now. We are in a state where things are working fine. Let's see what let's at least see this delete part, because it's something very interesting. It'll trigger an exception right now because we have modified the rel, so we need to migrate it. We have not written the migration code right now, but just to make it work, I'm just deleting the whole application. So when the application is in production, we need to make sure that the database migration happens properly. Otherwise that will lead to data loss. So migration is something which we can take care in the future episodes. Right now let's concentrate on this feature. So let's rerun it. App works fine. Let's create object 1 that is working. 2, 3, all done. Let's now set it to done. It goes here. One more to done. Maybe send it back. Let's send this to the bottom. Now the delete is interesting. Let's see whether we get a callback. We are deleting item to do item with ID 2. Remove. Triggers a callback. So what is the item which is come for delete? So remove it, index 2. So what's the item? We have a track of what was the item which was deleted. As you can see, it's item 2 with to do item 2, and it's showing index as 3 because we removed the last item. So this can safely delete it from the view model. And now let's trigger the permanent delete. Works fine. Let's delete this one as well. That's also deleted. So the interesting piece is to see whether that got really deleted or not. So let's just run the application once more and see. We should only see one item. Perfect. Everything is working correctly. So that's a brief introduction of using Realm with RxSwift and MVVM. Pretty complex, isn't it? Because we have 3 layers coming in and we have to maintain the same indexes and everything in the view model whenever there is a change happening to the Realm. So this was a slightly complicated way of starting Realm, but then I got to tell that this would have been something very relevant and informative for all you guys. So until the next episode, have a great weekend.